If you want to learn how to script, this video is made just for you. My goal is to get y'all to understand why something works rather than just knowing that it works. The 5 fundamental parts of programming are variables, conditionals, functions, loops, and tables. By mastering these, you can pretty much do anything that you can think of, but I'm going to give tables its own video. Now before we jump in, this is how I'm going to format this series. This is where most videos stop. The last 2 parts are the most important part of the entire video. I cannot stress enough how important the challenges are. Also, if you've already learned some of the concepts in this video, feel free to skip to any of the timestamps I have set. Now let's hop in the studio. So there are 3 panels you should always keep open. We got the output, properties, and the explorer. So let's go and open up a script. So to create a variable, all you gotta do is type local, and you can name this variable whatever you want. All it has to do is start with a letter of the alphabet. 3 different data types we have are numbers, and then we have strings, which can hold a string of characters, and then we have booleans that are holding a value of true or false. So now to use these variables, we've named it something, string, booleans, and if we want to go ahead and use these, we can go ahead and print them out. Print out numbers, or wait, no, we got something, string, and booleans. So now if we go ahead and run this, you can see that it's printed 2013, the string, and false, which is exactly what we have in these variables. So right now these variables pretty much have no meaning. You might be wondering what are they even used for. So let's give them some meaning. So let's say we have level, and let's say our level is 3, and we can go ahead and print level, and it's 3 right here. And then let's say right here we leveled up, so we can do level equals level plus 1. And now if we print level, it's going to print 4 right here. And so if I go and run this, as you can see, it prints 3 and then it prints 4. So we have edited what was assigned to level. And there's actually a simpler way we can do this. We can just do plus equals, and then we can do 1. And that's the shorthand version of just writing level equals level plus 1. Now you can do this for any sort of operations. We have minus equals 1, and we have divide equals 1, and these are just the shorthand version of doing level equals level divided by 1, or minus or plus or times. So this isn't the only way we can modify variables. We can have multiple variables or level. We can call this one gain, we can do 6, and we can modify level by using our new variable gain. And so we can do plus equals gain. And this right here is the shorthand version of doing level equals level plus gain. And so now right here, this is going to act as level equals 3 plus 6, and so it's going to be 9 if I get rid of this line. And so if we try this out, we should get 9 in the output right there. And so now level was incremented by gain. So that's pretty much how numbers work. Let's go ahead and talk about strings. So strings can be named anything you want. I'm going to name mine super, this is my username, and you can go ahead and print these and it'll print the output like we talked about. But what if you wanted to edit this string? There's many ways you can edit the string, but the one way I'm going to go over for this video is we can do ... and we can add other strings to it. So I can add is awesome, and it's going to say super right here, ... and it adds this is awesome. And this right here is called concatenation. Whenever you add 2 strings together, that is concatenation. So if we run this, as you can see, it's going to print super is awesome. It concatenated the strings together and it printed it out. So this right here doesn't actually edit the variable. It's just editing it inside this print, and then it's going to print it out. If we want to actually edit the variable, you can do ... equals, and we can add is awesome to it. And so now if you print just name by itself, it's going to print the entire string. This just looked a little bit gross, but that's just the shorthand writing of name equals name ... is awesome, and we can print this out, and it's going to run twice super is awesome. So let's go ahead and move on to conditionals. I'm going to define some basic variables. So say I have coins of 500 and my level is 1, and now to do a conditional, you can do an if statement and we can do coins, and we can do greater than equals 100 then. So if my coins are greater than or equal to 100, it's going to run inside this little block right here. And so what I want it to do is I want it to add to my level. I want to add 1, and then I want it to take away from my coins 100. So now if I have more than 100 coins, it's going to add 1 to my level and take away 100 coins. And so at the very end of my program, if I print level and I print the coins, if I run this code, you'll see that I'm level 2 and I have 400 coins. Now the next part to if statements is that we can also do else. Now this part right here runs whenever this statement is false. So let's say I have 5 coins. Now this portion is not going to run. I can say print 2 broke. So now that I don't have over 100 coins, if I run this program, it should print 2 broke because I don't have enough coins. Let's go ahead and try and change this up a little bit. Let's say we have this boolean called a forward. Now we can just take this right here and we can move that to a forward, and now we can just put if a forward there because this is now a boolean. We're setting it to the value of coins greater than or equal to 100. So if we print a forward, it should either print true or false because this is a boolean expression. And then it's going to check it down here, and if it's true it's going to add level, and if it's false then it's going to do 2 broke. So as you can see, it's false because we don't actually have enough coins. Also, one way we can make our prints a little cleaner is you can actually do some text here, level, and then you can concatenate the level onto it, and so now it's going to print level here. We can do the same thing for coins if we wanted to. We can do coins, and then we can have the coins variable here, and so now it's going to do level colon and then add level, and the same for coins. And let's go ahead and give us some coins so that we can run something. So if we run this, boolean's true because we can afford it, our level updates to 2, and our coins change down to 150. So you can kind of start to see how these basics are used all the time in games, and how you really need to get these down to be able to do pretty much anything. So let's go ahead and make this a little more complicated. Let's add another variable, call it stone, and let's give us around 100. There's more things we can do with booleans. There's things like and or. I'll just do those 2 for now. So let's say we need both. We both need to afford it, and we need stone to be greater than 50. So it needs to be 50 or greater if we want to buy it. So now both of these booleans need to be true for us to be able to afford it. So now if we ran it at this point, it would still work because we have 100 stone, but if we have 50 stone, but if we have less than 50 stone, as you can see, it's going to say 2 broke. We can afford it, but we're 2 broke because we don't have enough stone. And so or, this one works a little bit differently. Now if we have or, just one side of this expression needs to be true. And since a forward is already true, it's not even going to check this right here because it knows it's or, and since this side's true, it doesn't matter what this side is. It's just going to run this program right here, and it's going to work. So if we have or, as you can see, we can afford it, and it's going to change our level up and subtract coins. Now, one more thing we can do with booleans is there's another keyword called not. And so basically what that is going to do, if we put parentheses around it, it's going to take this boolean, whatever it results to, not is going to flip it around. So if this is true, this is going to change it to false. If this is false, this is going to change it to true. So if we run this program to see what happens, it changed to false because we originally had 250 coins, which is enough, and it was true, and it flipped it to false with not. So that basically just inverts whatever boolean it's tied to. We can also chain these if and else statements. We can continue it on, and we can add an if here. So now it's an else if, and there's this red line because we don't have a boolean expression here. So let's say this means that we can't afford it, and we also don't have enough stone. So let's say we can't afford it. Let's go to 50. Let's get rid of this not. So we can't afford it. We also don't have enough stone. And let's say, but we have at least 25 coins. We don't have 0. We have at least 25. 25 to 99 is going to be in this range because we don't have any stone. We're less than 100 coins. But we have greater than or equal 25 coins. So right here we're going to print some coins, and then we can move this to the last else statement. So now we can't afford it, but we do have some coins, but we aren't like insanely broke. So if we run this program, afford is false, but we do have some coins, and level doesn't change, coins don't change. Now I'm going to move on to functions at this point. So let's go ahead and get rid of this, and I'm going to define a function, local function. I'm going to give it a name. Let's call it buy. And so press enter, and here's our function, everything inside this block. And these right here are the parameters. So I'm going to make this the type of upgrade that you want to buy. So that's a parameter you can pass in. To call this function, you just type buy, and then as you can see, there's my variable parameter, and I can pass anything on one side here. I can pass in 10, and if I were to print type here, this would be 10, and you can call this again, and so now it's going to print 10, and then it would print string. So if I just test it out so you all can see, we have 10 and string. So now let's say I want to use this type to figure out which type of upgrade I want to buy. So this will buy upgrade 1, this will buy upgrade 2. So I can do an if statement, if type, and to check numbers, you're going to do equals equals. That's how you can check numbers. So if type equals 1, then we're going to do this. But if type is 2, then we're going to do this down here. So this will be buy upgrade 1, and then this one down here will be buy upgrade 2. So if I were to run this, as you can see, that one's going to buy upgrade 1, and this one's going to buy upgrade 2. We can take this a little farther. We can do, if we buy upgrade 1, it's going to increase our level by 3. And if we buy upgrade 2, this is going to increase our level by 10. So just to see that this works, we can print level on both of these. And so our level starts out at 1. We call buy 1, we call buy 2. And our level is going to upgrade to 4, then it's going to upgrade to 14. Because after this first upgrade, it added 3. Then after the second upgrade, it added 10 to that. So it went to 14. Also, functions don't need parameters. You can just put them in if you want to. So I just put a parameter in here. Also, type is not a very good parameter name because it is also a keyword, so just keep in mind of that. I can change this to T to make it a little better. You can just name whatever you want. But yeah, it just doesn't need parameters. You can do no parameters if you want. You can still call it. This will just be null because I'm not passing anything in. And you can also do as many parameters as you want. So these are all just variables like we've talked about, but they're defined by whatever you pass in right here. So now T will be 1, A is 2, B is 3, and C is 4. So that's how the parameters work. Also, I don't know what I was talking about this. This just means that this side equals this side. That's basically all that means. So T equals 1 means that T is 1. That's what that means. Now the reason there's a tab after functions and if statements is because each of these things have a scope to it. You can slightly see this gray line that goes down here, and this right here is the scope of this if statement, this right here is the scope of this one, and this is the entire scope of this function. So if I were outside of the scope, like over here, and I tried to print A, as you can see there's going to be a red line and it would error because this A only exists inside of this scope. Also, one other thing, the variables, everything is only defined after the fact that you define it because it runs top down. So if I tried to print level above level, as you can see there's a red line because level currently does not exist. The last thing I'm going to go over for functions is the return statement. So if I had, let's say, a function that gets a color and I pass in a choice, now I can check this choice. Let's say the choice is 1. It's going to run inside here, and if the choice is 2, then it's going to run here. We have a return statement, and what this is going to do is it's going to send back a value to whatever called the function. So let's say I have two different options here. I have blue and green, and now down here I can actually use this value. Let's say the color equals, we're going to call the function getColor, and we're going to choose option 1. So now if I print color and run this, you'll notice it prints blue. So it actually returned this value back to where it was called from. So how this runs is we are on line 10, go to line 11, color equals get color 1, so it goes up here, passes in 1, it runs here, oh, we find out, choice equals 1, it returns blue, we go back to here, now color equals blue, and then I printed it out. One thing about return is that as soon as return is used inside a function or wherever it's used, it's going to immediately exit the function. So if I had farther code down here, and say I print something at the end of the function, it's never actually going to reach this print because it returns either here or here. So if I ran this code, as you can see it prints blue, but it doesn't print something. The only way this would actually print is say I got a color that was 3. It's not going to reach any of these options, so it never returns and it just prints something. And color should print nil. So it printed something and it printed nil because no color was actually returned. So nil value was set to color. Now the last thing I want to go over before I put everything together is loops. And loops have a start and they have an end. And I'm going to go ahead and define these as variables. You don't need to define them as variables. And to start a loop, we're going to create a new variable, and I'm going to name mine increment. And we're going to define it to be start to the end, which is stop for me. And then you end it with do. And so now if we go ahead and print this out, I'm going to print out increment. This is the new variable we defined. It's going to start here and it's going to stop here. By default, it's going to increment by 1. A better way of doing this is iteration actually. This will be an iteration, and this is going to demonstrate what's happening in this loop. Every iteration is going to print this right here, whatever this equals. So if I go ahead and run this, you'll see it'll print 1, 2, 3, 4, 5. Because it started at 1 and stopped at 5. These variables represent what each part of a loop is, but the most traditional way is you have for I equals, and then you choose some numbers here, and this will do the exact same thing as before. So if I go ahead and run this, you'll see it 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now, this next part of a loop is what really opens up the bounds of what we're allowed to do. So this is the start, this is the end, but there's a third number that you can put in, and this is an increment. So I could change this to 3, and this is what it's going to increment by. So if I change this to something like 7, and if we do print I, and if I go ahead and run this, you'll notice it prints 1, 4, 7. And that's because it's now incrementing by 3. So you might be wondering at this point, what happens if our start number is higher than our end? Or what if we have our end at 8 and since it increments by 3, it's never going to reach 8, it'll go from 7 to 10. And how it works is it's going to start at 1 and then it's going to do the loop. Well, it's going to check, is 1 less than 8? And if it is, it does the loop. And once it gets back, it does it over and over and over. And as soon as it realizes it's greater than the stop, it's going to immediately stop after this increment. And it's going to check immediately from our starting number. So if I had 9, 8, it's not going to do anything. As you can see, nothing prints in the output. And like I said, if it starts at 1, it should stop at 7 because after it adds to 10, it realizes it's going to be past 8. So it's not actually going to do anything with that. But if this were at 7, it would still do the exact same thing. I would have to change it all the way to 10 if I wanted to see a difference. Also, if you didn't already realize, it's going to run from top down. So if I printed something up here, then first this prints, then the loop runs, and if I had something beneath it, say this for the end, it's going to print start, it's going to print all of the loop, and then after it's done with the loop, then it's going to continue and print end at the very end, and it's going to run all the code that is down here. So it's going to run top down. So if I ran this, just for example, start and then end after. This can get complicated really fast after you add some more things into it. Before I go into that, there's one more thing about these loops, is I as a variable like normal, but if I tried to add 5 to it, you would think it's going to first start at 1, add 5, so it's at 6, then it prints 6, then it adds 3, then it'll be 9, and then it does it again and it's going to go past 10, so it's only going to print twice, you would think. But if I go ahead and run this, you'll notice that it prints 6, 9, 12, and 15. And this is because these loops, they're predefined, and whenever you edit I, it's not actually going to do anything. So it's going to take 1, add 5 to it, it's going to take 3, add 5 to it, and or 4 and add 5 to it, and so on, and it's not actually going to change the structure of how the loop already runs. This is different from other programming languages where when you edit I, it will actually change the way the loop runs. It won't just be immediately defined up here. You can usually edit it inside the loop, but in Roblox you just can't do that. Now, loops is where we can use two new keywords. So let's make an if statement. Let's say I equals 4, and we can do something like continue, and this is a new cool keyword that we can use. So I'm going to print I down here. How this is going to work is it's going to start at 1, it's less than 10, so it's going to run, and it's going to check, is I 4? It's not going to be 4, so it prints 1, and then it goes back. Now it's going to be 4, and when it gets to this continue keyword, what continue does is it skips the rest of the loop, and it starts back at the next increment. So as soon as I equals 4, it skips at everything, and it immediately increments it to 7, and then it continues again. So if I ran that for an example, as you can see, it skipped 4 because I put continue on it, and it just skipped the rest of the loop. The last keyword I'm going to show you is called break. So if I replace this one with break, it's similar to continue, but it's going to, instead of go back to the next iteration, it's going to immediately break out of the loop. So if I ran this, it's going to only print 1, and it just exits the loop because once it equals 4, it breaks and it stops. If I change this to 7, and I ran this, as you can see, it prints 1, 4, and at 7, it exits the loop and it just continues code down here. Now I'm going to try one more complicated thing. I'm going to do a loop inside of a loop, and I'm going to make these the same increment, and for now I'm just going to make it print the values. So it's going to print I, then it's going to print all of j, then it's going to print I, and just so it doesn't get confusing, I'm going to add this string right here so you can tell what is what. So if I put this here, change this into I. Now let's go ahead and run this, and as you can see in this output, if I go to the very top, I is 1, then it prints j all the way 1 to 10, then I is 2, 1 to 10, I is 3, all the way down till I is 10, and it prints j 1 to 10. So you can easily calculate how many times this runs. So I runs 10 times, j runs 10 times inside of I, so in total it runs 100 times. Now that we have a rough understanding of the fundamentals, I'm going to create something rather fun for us. So let's say this represents x and this represents z. I'm going to get rid of these prints. I'm going to generate a grid using these coordinates. So let's say I pass in an x and a z value, and we haven't gone over this, I'll explain it in a second, but let's say we have a part, and it's going to equal instance.new, and I'm going to create a part, and now with this part, I'm going to just set its size to, we'll do 1, 1, and then I'm going to set its position to a new vector, and it's going to be x and z. I'm going to put it in this guy, I forgot. There's 3, okay. And I'm going to set the parent to be game.workspace. So now this creates a part, and it's going to set the size to a 1 by 1 by 1 tiny little block, and it's going to change the position to be this x coordinate I pass in, the z coordinate I pass in, and 5 studs, however high that is. Then it's going to set the parent in workspace so we can actually see it. And now all I'm going to do is I'm going to create a part in every single iteration. So at the end, this is going to create 100 parts if I pass in x and z. One more thing, so the parts don't fly everywhere, is I'm going to anchor them. So I'm going to set anchor to true so they don't just fall out of the sky. So if I go and run this, as you can see, I have this grid right here, and I can select each of these parts. These are all separate parts, and I generated this grid by using this loop and a function. Now, to explain how this works, we've gone over loops, we've gone over functions. This is called for every iteration of z, and this entire loop is run for every iteration of x. So this is run 100 times with each unique coordinate of x and z. Now in this iteration, this right here is instance.new. Instance.new just basically lets you create anything you want. So if you go in the workspace and press this little plus sign, you can create any of these things, inside instance.new. So if I wanted to create a tool or a folder inside a script, I could just type folder, and here is my folder right here. Since I don't want to just create it and not be able to use it, I assign it to a variable. So now this variable equals this new part I created. Now that I have access to it, I can edit it however I want. So if I have a part, and you click on this part, we have this properties page, and it has all these properties we can change. And how we can change those is all we have to do is give part and dot the property you want to change, and then you can just change it and set it to a new value. So size uses a vector 3, so I had to pass in a new vector 3, which is x, y, and z. And then position is another vector 3, but this one I want to use x and z because this one I want to change based on whatever I pass in. And then anchored just means I can change it to anchored, so it's either false or true. It either has physics or it doesn't. And then I changed the parent to workspace, because if I didn't do that, this would just be a random part in code, and it wouldn't have a parent, so it wouldn't exist anywhere in the Explorer because I didn't assign it to a parent. So this part right here, the parent is the workspace. If I moved it here, the parent would be the base plate. Now I'm going to try and make something a little bit cooler to open your eyes to the possibilities. So let's go ahead and make 100 x. So it's going to go, I have 100 parts in the x direction, and let's make this a little bit fancier. We can use math, and there's a bunch of math functions we can use, but one that I'm going to pick is I'm going to use sine. I'm going to put x inside there, and I'm going to offset it off the ground by 10. So it's 10 studs in the sky plus whatever the sine value is. So as it goes across the x, it's going to produce this sine offset based on whatever the sine value is. It could be like -1 to +1. And so with that, we should get this really cool wave effect. So if I run this code, as you can see, there's this nice little sine wave of parts as the x changes. And if I wanted to make it smoother, I could divide this by 5. So now it's going to have a less, it's going to change across the wave slower because x is now a fifth of whatever the value was. So now, if I run this code, as you can see, we got this nice smooth wave. And as you can see, we can create a lot of really cool things with this. Just to see what happens, we could say, try also adding, let's do z, and see what happens when we do that. If we run this code, we get this really cool effect where it's tilted on the z-axis. And if I want to see a little bit more of what's going on here, I can make it go faster, and let's also make it go 5 times farther in the z direction. And now we have this really cool grid wave effect going on here, where it's changing both in the x direction and the z direction in this really cool wave effect. Now I'm going to take it one step farther, and I'm going to change the color. So there's a few different ways you can change colors. We have .new, .fromRGB, HSV, but the one that's going to suit me best for this is HSV. So HSV represents hue, saturation, and value, and hue is the value that goes across, so this is like a rainbow effect. Saturation is how much of the color we have, so it goes to white and to the full version of that color. So this is high saturation, this is low saturation, and then we have value. This is how bright it is, so we go all the way to black, all the way back to the color. So I'm going to try and create something cool. Also, you realize it ranges from 0 to 1, so this is 0, this is 1, and same with saturation and value. So I like 0.7 for saturation, so I'm going to use 0.7 for saturation and value, and I'm going to try and make a cool rainbow effect. Since it only ranges from 0 to 1, I'm going to take x and z, and I'm going to divide it by, let's say, 200. So it's never going to reach something, because the highest value we have is 150, so it's never going to reach 1, which means it's not going to break the bounds. And we're just going to add x and z together, divide it by 200. So now as x and z increases, it's going to go across the rainbow. So if I try this out, you'll see that it starts around 0, which is red, and we have this nice rainbow effect going across our wave of parts. Now this last thing I'm going to go over is while loops. So with while loops, it's going to take a Boolean expression, And while this Boolean expression is true, it's going to run the code inside the while loop, and as soon as it turns false, it's going to exit the while loop. So if I put while true here, it's never going to exit the while loop because there's no possibility of exiting the while loop. But it works the same as continue and break. So if I ever put continue inside this while loop, it's going to skip the code and go to the next iteration. And if I ever put break, it's going to exit the while loop no matter what, and it's going to continue the code after the loop. So if we have a loop that runs forever, it is going to be a little bit dangerous. You could crash your program. So one way we could do this is we could put wait up here, and this will wait the smallest amount possible. If you want to go a little bit smaller, you could do task.wait. Doesn't really matter too much though. This will act as a true statement and it'll run forever, but it'll also wait the smallest amount possible, so it doesn't try to run a billion iterations as fast as possible. So now with this while loop, I'm going to do some experiments using this while loop. For now, I'm just going to use this spawn plate just so I don't have to create a part, and I'm just going to do some fun things with it. So inside our while loop, first I'm going to gain access to this spawn location so I can change it and do things to it. So I'm going to create a variable for it, and this variable is going to equal this spawn location. So do game.workspace, and spawn location is a child of workspace. So to access it, all I do is dot and spawn location, and the parent of spawn location would be the workspace. So I could do parent dot spawn location, and that would be the same thing, though that is redundant. Now that we have this spawn location, I'm going to go ahead and try something out. Let's go ahead and change the position. Let's say we want to increment the position by a vector 3, and let's move it along the x direction by 0.01 studs, and we're going to change nothing else. So position equals position plus this new vector 3, and it's going to move along the x direction by 0.01 studs as fast as it can, waiting this much per change. So if I run this, as you can see, our spawn location is slowly moving in the x direction. I'm going to try one other thing. Let's say I define t equals 1. I'm going to try and rotate the spawn. So t is going to represent a rotation, and I'm going to make it increment by 1 every iteration. And so this is going to be 1 degree, and I want it to rotate all the way up to 360 degrees and go back to 0 and rotate 360 degrees again. So one way you can do that is we have this percent operation. So I could do t equals t percent 360. So what this does is it takes 3, divides it by 360, and then it equals the remainder. So if I had 5 divided by 360, the remainder is 5 because it can't divide, and 5 is the remainder. If I have 360 percent 360, then it's going to take 360 divided by 360. There's no remainder because it equals 1, and so it would equal 0. So then t, once it equals 360, it resets to 0, which is exactly what I want. If you had something like 365 percent 360, this would result to 5 because I have a remainder of 5. And the name for this percent sign is modulus or modulo, so that's what people call that. And so this is going to increment t all the way up to 360, resets to 0, all the way up to 360, and it just continues that forever. Now I'm going to do the rotation aspect using our new t that constantly increments from 1 to 360. So CFrame is similar to something like position, but this represents rotation also. So I want to change rotation. Position doesn't have rotation attached to it, and I want to change rotation. So I'm going to set it to a new CFrame, but I want to change it to the spawn position. So now this CFrame is a CFrame that represents the spawn, the position of it, but it strips it of any rotation that it has because, as you remember, position is a vector 3, it has no rotation, so this new CFrame I create has no rotation. Now I want to rotate it with my new t value. So to do that, we're going to multiply our CFrame by an angle, and I'm going to rotate it in the x direction. And this takes radians, so I want to convert my degree to radians because I'm using degrees 1 to 360, and I'm going to convert that to a radian, and then I'm going to rotate it nothing in the other directions. This is just going to rotate in the x direction by a certain degree. So now if I go and try this out, you'll notice that it's rotating along the x direction and it's spinning in a circle. And I'm going to go ahead and try another direction. What if I try the y direction? Spin in two directions. And so as you can see now, it's spinning a little chaotic. It's spinning both the y direction and the x direction at the same time. You can do a lot of cool things with this. Now this video is already around 35 minutes long, and I don't want it to go on forever for my first video, so I have set up 4 different levels of challenges for y'all to do after this tutorial. So here's the first one. It's this staircase. We have 4 parts, and it just goes up 1 stud as it goes up. So you try and generate this using a script. The second one is a cube that slowly changes colors over the rainbow and repeats it forever. And then this one does the same thing, but it's moving in a circle forever. And then this one is just a generated circle using a bunch of parts, and it generates a full circle. So those are the 4 challenges I have set up for you guys, and the goal for these challenges is for you to be able to write each program on your own by yourself without using any help. And this is just inspiration. I've set some different difficulties if you want to try to progress as much as you can. You should be able to do each of these with just the tutorial I have given you, and I will give the solutions to each of these challenges for the code I wrote in my next video, so y'all can see how I did it if you didn't figure it out, or if you just want to see how you differed from mine. Also, if anything was confusing, you could join the Discord that's linked to my channel and ask any questions there. I'd be happy to answer. The last time I asked y'all to subscribe, I went from 8 subscribers to 800 subscribers, so if y'all do that again, I'll be at 80k now. But seriously, 99% of you aren't subscribed, and if you want to see more content from me, just let me know by interacting in any way you want, and I'd very much appreciate that. See you guys in the next one, and thanks for watching.